This is the code for LAB06 using the ultrasonic sensor to help drive the Romi Robot. So we'll go over, I'll try not to go too long on the things that we've gone over before. We have some of the static variables we've seen before: wheel diameter, wheel base, count per revolutions, that's all the same. Max speed, minimum speed, button delay of 2 seconds, serial delay, that's added that into when I take some of the delays that are caused by serial prints are actually needed for what I'm doing. This distance 1, this will help us go basically 40 centimeters, so we can be 80 centimeters away from the wall. We have our trigger pin, echo pin, inches defined, centimeters defined, and millimeters defined for our ultrasonic sensor. We have some dynamic variables that change. Ultrasonic, that's just a float that I'm using to store some of the ultrasonic values. I'm also having an array of size 5, renaming that array. I'm using a medium, or I'm trying to use the medium value from that array. I have an integer named pass. This is just to help the microcontroller realize where it's at in the loop. Setup is the same. We have, we're declaring the trigger pin and the echo pin. We're setting them up. We're waiting for the button to be pressed. Once the button is pressed, we go in the void loop, and the green LED will turn on for 2 seconds, and then it will turn off, and we can see that down here. I should go here. So it calls this function the green LED. So it makes sure the red LED is turned off. It turns on the green LED. We delay, which was 2 seconds, and then we turn the green LED off, and then we go on to the next function in the loop, which is drive straight. And distance 1, so it'll go distance 1, we said 40 centimeters. Here we have our drive straight function. It's a excuse me. It's a function that's taking the inputs to the left speed, right speed, and the distance. The distance we're also calculating from the ultrasonic sensor. So let's see, we get the distance from the sensor, we take it, we do our pulse calculations. I'm also passing what loop we're going through in this. Some of this is the same. While the left count and the right count of the encoders are less than pulses, it will go forward. Once it's not, it will, it will stop the motors. Yeah, and we'll keep going through those, and I'll show you what happens here. So in this function, we will, right after the first distance 1, after we go and stop 80 centimeters from the wall, the ultrasonic sensor will read the distance, and we want to go half that distance. After that, it will stop, and then it hopefully will be 40 centimeters from the wall. After that, we want it to read the next distance, and we want it, and we hopefully, it'll be going 20 centimeters from the wall. It'll read the next function and divide, and we'll go half that distance. Ideally, we'll end up about 10 centimeters from the wall. The last function, of course, same. We're hoping to end about 5 centimeters from the wall. Once that's over, we wait for the button to be pressed, and it will stay there. The red light will come on as well. Oh yeah, so in this pass function, when it says 5, the red light comes on. In our float gets distance, it's the same as the Romi Robot that was Romi Robot example that was given to us, except I'm trying to put in 2 filters, one being an array. The other filter is, we know that the ultrasonic sensor reads distances between 2 centimeters and 400 centimeters. So therefore, anything that's not within that range, I want to kick out, and that's what I'm doing here. After that, we have the array. This is the array example provided to us. What this does, it just puts it in order. The arrays in order of the value. And what we're trying to do now is to take the median of that. and I found online there was an example from Code Academy that helped calculate the median. However, I was able to use this median in the Romi Robot basic function, and it worked correctly. However, in this program, it doesn't. For instance, this distance calculation really should be equal to the median. When I do that, it messes up the function within the loop. So even though it's not correct, I am not going to have those two equaling each other. If I had more time, I would hone in on that and see what was going on with that. But that's it. Here's our robot. We're going to upload the code. So we'll go ahead and do that. Let's see if the code is done uploading. Real quick, we'll take a look at the track real quick. So ideally, this is what we're looking at. It is approximately 120 centimeters from this line to the end of the door. So what we want to see is our robot start at the 120 centimeter mark. We'd like it to stop here at the 80 centimeter mark, then calculate the remaining distance and go half that. But hopefully it'll stop at 40 centimeters, then 10, and then 5, and stop there with the red light coming on. So we'll put this here, set this up a little bit. We'll make sure that we have the weight, because we have the front ball is off. Now, there is a problem with this. It seems to want to skip a couple of these. Most often it wants to skip the 40 centimeter. Still working on that. Haven't quite found the solution yet, but you'll notice that during the video here. We'll go ahead and let me see, hit A. Green button is on for 2 seconds and it goes off. We'll follow it. So it stops at the 80. And like I said, this is going to be it probably will not stop at the 40. And it will probably stop right at the 10. That's where the front of the ultrasonic is, and it stops right about at the 5. So let's see where we're at. We actually appear to be, looks like 6 to 7 centimeters away from the wall. So not perfect, but given the time, this is my submission.